Hello, welcome on our presentation about debugging for iOS platform. We are both thrilled to present for you today, and we wanted to thank organizers and program committee for accepting our talk. I'm Ewa, I'm a software test engineer.
And my name is Henryk, and I'm a mobile software engineer. We work together.
That's a wake up.
So the presentation is officially started. We work at Allegro in Poznań, and we're working on the buyers app of Allegro. Today we would like to tell you a few tips and tricks that we do while debugging. As you all know, debugging is the art of finding some problems in your application and correcting them. Splitting this into 3 steps. That's, first of all, what's going on? First of all, finding the bug, because if you're not aware that something is not wrong, you're not going to be able to fix it. Second, the second step is diagnosing the problem. That is, isolating the source of the error, finding as much information about it as you can, and finally, posing a hypothesis, what went wrong, and how to fix it. And then finally, in step 3, if you're pretty sure what is the problem, you have to validate your hypothesis in an as efficient way as you can.
So we want to talk about both our experience we gathered in Allegro, so tools that we use and tips and tricks, but also about knowledge that we gathered from, for example, WWDC sessions, some presentations, and blogs about debugging. Okay, so let's start with finding some bugs. Allegro was stated in the 2000th year, and it was a web page where you could buy and sell goods. And the web channel was the main one for a really long time. But already 3 years ago, Google announced that more than half of the Google searches comes from mobile devices. And this trend is reflected also in Allegro. But as developers, we shouldn't care whether the user prefers Android phone, iPad, or desktop. We should rather focus on the good quality and the user experience on any device user prefers. Okay, it is trivial. Less trivial question remains how to do it, especially in the company that is originally web-based one. So the company where most of the IT compartment consists of web developers, front-end and back-end ones. I really like the answer given by Daniel Knott in the presentation, how to scale mobile testing across several teams. So if you are interested in this matter, I recommend this presentation. But today we would like to tell you more only about one of the things that we do in our company to support mobile application quality. Let's imagine a situation where backend developer wants to introduce new feature. Let's say this new feature is a new filter available on the offer listing. So usually what they do, they check this change on the test environment. They check it on the web front. So they are checking different browsers on different systems. They may be checking also different screen sizes. But they would like to also check this change on the iOS mobile application. And here a few problems arise. Because iOS development is a closed one, so to compile iOS app, you need to have a MacBook. You may need to know Swift or Objective-C to know how to configure app with a test environment. Moreover, you can be living somewhere else than Poznań, the place where we work, so you may have a problem to drop by and borrow a device from our team. So in these cases, we usually invite people to install Allegro Lab. This is a special app version that is debuggable without a debugger. And what are these debugging features and why we think they are interesting? There are actually 2 debugging features that distinguish Allegro Lab from regular App Store version. The first one is a tool called Twix. Have you ever used Twix before in your project? Somebody? Okay, you get a mug. So Twix is a tool that is available after shaking a device, and Twix helps developer to adjust different parameters in iOS app. This parameter can be animation timings, enabling, disabling new features. So this is the first tool. The second tool is called Flex. Have you ever used Flex in your project? Okay. Can you get the mic for them? Thank you. Delegation, yeah. So Flex is a set of in-app tools for exploration and for debugging. So these tools, as soon as they are implemented in your project, they are available for use with no code changes. So you just need to know proper gestures. So for Twix is shaking device, and for Flex is a double finger tap on application screen. So let's talk a bit more about Twix. So as we already know, it's available after shaking device. Then the view with a cell with label networking appears. This is a case of our application. And then the custom view with some adjustable values appears. So as we already know, Twix helps developer to adjust different parameters in iOS app. In our case, these parameters are the environment addresses. So with Twix, you can easily switch between production, development, test environment of your choice. So without any knowledge related to iOS, you can easily configure the app with a, for example, test environment. So as you can expect, it's really helpful for the teams that are not iOS developers. So using Twix, in this case, backend developers can test their changes on the environment of choice with using Twix. They are more independent and they contribute to mobile quality in this matter. How to use Twix? They are available as a Cocoa Pods. We use them to configuration, debug, and lab. Traditionally, Twix are available after shaking device. So if you want to use that gesture, what you need to do is to replace your root UI window with a Twix shake window. And the smallest configurable value is called FBTwig value. So instead of returning Boolean here, we return FBTwig value. So here is the title of entire category, networking. Here is the title of group, environments. And then you have a label for tests. And then no, so it means that is disabled by default. And actually, that's it. So as I said, with the use of this tool, iOS developers, web developers, everybody can configure the app with the environment of choice. OK, but we said about the tool that is available within Allegro Lab, but we haven't yet said how we invite people to install this special app version. So we have a Bamboo plan that is available for everybody in the company. So it uses Fastlane under the hood, and it uploads our app to Fabric. Fabric is a place where you can invite individual and group of testers to test your app, to download it and install. As you can see, you can actually track how many people accepted, installed, or launched the application. So you clearly see who is using your app or who is not. And as soon as they are invited in Fabric, they get email notification, and they can install the app or install an update if they are already using it. OK, that would be all for Twix. Now let's talk a bit more about second tool, Flex. So as we already know, Flex is a set of in-app tools for exploration and debugging. And debugging is something that concerns us the most. The most interesting feature about debugging is network debugging. So basically, we can see detailed network history with the timings, responses, and headers. And each request that is done using NSURL session or NSURL connection is then visible via this networking debugging tool. As you can imagine, it's pretty convenient because I personally experience this situation a lot. When I'm using an app, I see a bug, and then without networking data, it's really hard to reproduce it. With Flex, I can easily find out what requests were made and what responses caused the certain app behavior. And these logs can be shared with other developers, so we can share the data, reproduce the problem, and hopefully fix the bug more easy and quicker. We used forked version of Flex because the original version does not support an option to as keep the networking logs after app is crashed or killed. So as you can imagine, this information may be very useful if you want to debug crash in your app. So our teammates used pin-cached library to actually keep the information about a networking layer after app is killed or crashed. So this networking debugging option is useful for both iOS developers and web developers. It does not require any iOS-specific knowledge, so you can easily find out about networking data and take advantage of it. The second debugging option of Flex is a view hierarchy. You can inspect and modify views that are displayed in your app. You can filter them if you want to see only information about buttons. You may select the view of choice and then call custom methods on it. You can also change properties, like there will be a change of the font of certain label. So this option is helpful mostly for iOS developers because it requires some iOS-related knowledge. So you need to know what are the methods and properties and what they are about. It may be also useful for people who are new to the project because you can easily find out by clicking some objects what is the class name and what is where you should put some changes, for example. And the third debugging option of Flex is view rearrangements. Not only you can select a view of choice, call custom methods, and change properties, you can also select a view of choice and move it around. So this option is useful for iOS developers who want to check some quick and simple UI concepts, but also for UX and UI designers. They don't need to know how to code. They may just play around with the app and show you, oh, it looks better, maybe we could change it. So to sum up, we have this debuggable version without a debugger that helps you to modify the app with the use of two tools, tweaks that helps you to switch between environments, and Flex, that is a set of debugging and exploration tools, out of which network debugging seem to be most important for us. And these two tools together support mobile app quality in our company. And that would be all for the first part.
Okay, so Ewa showed you a lot of tools that let you check your app really thoroughly, and hopefully you found no bugs. However, life is a little bit hard, so most probably at some time you will. So we're at step 2, diagnosing a problem and checking what's wrong with your app. I'd like to show you an example from our application from some time ago. At the beginning of this year, we were migrating to new layouts to support iPhone X and all new screens that had edge-to-edge screens. And we were updating a lot of UI code in our app. We were updating layout margins to properly support the new screens. And suddenly, we got information from one of our testers that if you use the app on iPad, and you click through several advertisements in a row, you're getting a very weird behavior. Changing the offers for the first few times is okay, but then suddenly, at some moment, the app freezes in a weird state. If you launched it in Xcode, you would see that in the Debugger tab, you see that the CPU level is maxed out at 99% while the app is unresponsive and the memory is slowly increasing. So pretty much that's an obvious diagnosis. We have a layout loop here on our main thread. So it was a very complex screen at that time, and we didn't know what was wrong because so many things could go wrong. So we passed over this issue to our UIKit expert, who decided that it's time to pull out a heavy cannon to solve this issue, the tool called the Layout Feedback Loop Debugger. It was introduced on WWDC 2016, so it has 2 years already. It's not a very young tool. However, I'd like to ask you how many of you have heard about this tool? Okay, so 2 people. Yes, the gentleman. Not only you know a great tool, but also you win a mug, so you're really lucky today. So what does the Layout Feedback Loop Debugger do aside from what you already figured out from the name that it helps with layout loops? If you use this tool in Xcode, Xcode will get additional logging capabilities. That means whenever a layout loop happens, extra information will be thrown to the console, which at one hand is extremely informative. However, As you will figure out pretty soon, the logs are really big. There's a lot of them, like a real lot. I launched a sample project in which there was a very obvious layout feedback loop. I made only one view controller, which in its viewDidLayout subviews method made its view dirty by calling setNeedsLayout, which led to a very obvious loop. And even then, on the first loop, Xcode dropped 529 lines of logs. In the example that I was talking a little more before, it was over a few thousand, so I decided that it's completely unfeasible for me to tell you about this in an understandable way. However, I'd like to take you through the logs, so for the future you will know what this tool can do. So, if you want to set up this, mode in Xcode, you have to edit the scheme of your app. And then in the section arguments passed on launch, click the plus, which will allow you to add more launch arguments. And then you input UI view layout feedback loop debugging threshold. So it doesn't say pretty much anything to me, so you have to trust me on the word that it means how many times a view will lay out itself before it is diagnosed as a loop. You pass a parameter over here, 100. That's how many times it can lay out itself. You can input any value, but it's going to be clamped between 50 and 1,000. And remember that arguments are prefixed with a dash. If you do it correctly, at the beginning of the app, you'll be informed by the console that the mode is on. And at the first situation when the layout feedback loop happens, you're going to be informed with a very long print of a stack, and there's a lot of interesting information happening here. The app will inform you that in this sample project that we had, upstream layout dirtying happens, which means that a view is updating either its parent or itself, which is illegal because this will lead to a loop. Aside from that, you get a pretty clear diagnosis that setNeedsLayout is called under viewDidLayout subviews, which is exactly the problem that we introduced and the tool found it, along with a call stack where it happened. Aside from that, you're going to get an exception that the layout is degenerate. You'll be informed in which subview this layout feedback loop happens, which was immensely useful in our iPad situation because there was like a lot of views, so it was pretty much narrowed down to only one branch of the views. The top-level view in which the layout feedback loop happens along with an array of views that receive layout in order. Here is just one view, but it could be 2, 3, 5, 10, 12 or more views laying each other in a circle. Finally, the app will crash with a generic exception. As you probably know, at any time you can in Xcode set up an exception breakpoint, which will help you to capture this exception exactly in the place in the code where the layout loop begins. So going back to our Allegro app situation, we figured out that in the offer screen, we were refreshing the layout in an animation, and there the scroll view was invalidated. That wasn't still informative for us enough. However, along with the logs that we used, we finally had a breaking point where this layout loop started, so we could profile the problem in instruments, and there we found out that update layout margins and update invert layout margins from SuperView gets called over and over and over in UIKit, which led us to a working hypothesis that the vertical layout margins of the whole view have been updating vertical layout margins of its child views, which is pretty expectable, which updated the content view of the whole view, which, due to the misconfigured vertical constraints we introduced while adapting the app to iPhone X, led to updating the vertical layout margins, which led to a loop. So we would have never found it if we didn't use the layout feedback loop debugger, which gave us extra info to solve this problem. Wrapping up this section, layout debugger logs, which are extremely informative, along with the possibility to set a breakpoint on the exception and pinpoint the exact place in code where the layout loop begins, and profiling the situation, handing over the session from expo to instruments, gives you much more info, which can give you a fresh perspective or even any starting point for your problem that you didn't have any idea how to fix. And there's another problem from Ewa.
So we saw the first example of step about diagnosing a problem and posing hypothesis. Let's have a look at the second example of this step. So once we have a bug found, we would like to know more about it. How to reproduce it, what is the possible cause of it, and of course how to fix it. Let's take a look at the real-life scenario from one of our last sprints. This is the bug that we noticed on the bidding screen. This is a screen where you can enter the bidding price of your choice, having in mind that there is always current minimum price. So as you can see, the notification view that is displaying error message is not fitting it entirely. So here it's missing some space. Surprisingly, it was not that easy to reproduce, because it appeared that you need 2 simultaneous requests with the same bidding price. So let's imagine a situation where 2 people bid the same offer at the same time. So the first request is successful, and this request increases the bidding price. So the second request is failing with the proper error message because the bidding price increased. So as you can imagine, to reproduce this bug is quite harsh, because you would need like 2 accounts, 2 devices, and trying to bid the same item simultaneously. So it's hard and quite ineffective. In such cases, we have a friend that we can ask for help, and his name is Charles. Have you met Charles in your projects? You get a, yeah, I saw the guy, he was the first one. You can give him the bug at the end, yeah. So I'm happy you know him. I hope you also like him as I do. So this is only an example of HTTP proxy tool. You can use any other proxy, like Meet proxy or any other. But basically, it helps us to view the traffic between the machine and the internet. How it looks in practice? Most of the time, I use Charles' tool called Rewrite. This is how it looks like. Within Rewrite, you can create your own sets of rules you will apply for a certain location. I will call my mobilization, and I add location of choice. This is an endpoint you want to stop. So here you have a path and a query. Then you click OK, and you add custom rule to this specific location. You can choose different types of rules. I will choose the simple one, response status. It means that for every 200 response OK, I expect to get 400 bet requests. I hit apply button, and that's it. Quite easy. So it seems that Rewrite tool seemed to be a good choice as far as reproduction of this bug is concerned. So actually, I can use 2 different rules to reproduce this bug. The first rule is URL rule. So I'm adding a new rule. I'm choosing a specific type, and I'm pasting a value. So with a price that is 1. This is the price that is lower than the current price of this certain offer. So right now I'm expecting that the request that is sent by the application will be replaced by the request that I'm specifying here and a Rewrite tool. So I'm also expecting a server that will return an error for me, and I will be able to reproduce this situation. So this is the first rule I can use. The second one is a body rule. So this time, I will choose different type of rule. I will choose body. And this time, I don't want to stop requests, but it's response. And again, I'm pasting a value that I'm expecting to get. This time, I'm pasting entire error structure that I'm expecting to get with a long error message that, again, will help me to reproduce this scenario. So Rewrite tool, using different rules, helped me to reproduce my problem. But Charles is much more than only rewrites. There's also like recording of the traffic, map local, remote local. I personally really appreciate map local. This is a tool that enables you to treat your local files as if they were part of a remote. So here in this example, this is an offer view. So with map local tool, we can easily switch between data that is fetched from the server. We can actually enable this tool in Charles, and while refreshing the offer, we will get the data that is saved locally. So if we want to test something and we don't want to recompile, we don't want to change the view, we can easily enable this tool and check some corner cases, debug some issues, and test. So it's pretty convenient. But as far as using charts is concerned, we also meet some troubles. It may seem trivial, but hitting apply button is very important. It ruined my few debugging sessions because I was not applying, but expecting some stubs to be returned. So remember about apply. Moreover, if you are expecting some messages, some errors, it's really important to know its exact structure. For example, in this case, it needs to have message code and user message. Moreover, you need to take care of formatting. For example, while preparing for this presentation, I was using double quotes instead of double primes, and I was getting a parsing error, not the error I was expecting. And yeah, it appeared that this is the cause of the problem. So to sum up, Charles is an example of HTTP proxy tool, and we really love working with him, and while debugging, testing, and developing. And if you are not yet using proxy tool, we truly recommend it.
Okay, so we've gone through 2 steps, from finding a bug and diagnosing the problem. And right now we're at step 3, validating the hypothesis of what went wrong. So we try to apply the fix to our code in the most efficient way possible. Again, using an example, a few weeks ago, I've been introducing a new function for the offer screen on our app. The user was able to click on a button that showed a web view modally, in which the user was provided with new information. However, no matter how hard you clicked the close button, the model view didn't go away, which obviously was a breaker. We couldn't ship it that way, and because I was the author of the feature, most probably I was the author of the bug. So I looked at the code, and I saw the view controller dismissing delegate that was used by the web view, and I saw that yes, it is implemented correctly, the dismiss view is being called. So my second guess was, did I remember to set up the delegate? And as I looked at the code where I created the web view, yeah, okay, there was the problem, I didn't set the delegate. I set the proper delegate, relaunched the app, happy that I'm going to ship the fix in under 2 minutes, and as I clicked the model screen again, unfortunately, nothing happened. So that wasn't the problem. So I looked into the declaration of the web view that was written by my friend, and I noticed there were actually 2 delegates, and I wired up the wrong one. I shouldn't have set up navigation delegate, just plain delegate. So I came up with a fix, and yes, and then tried again, and finally I could ship the fix of the model screen. However, as you see, I spent about 30 seconds debugging with you, less than 20 seconds applying fixes, and as I recompiled my app twice, I was looking at the screen like a stupid person for over 5 minutes. So I thought to myself, there's got to be a better way to do this, right? So if at any situation you're recompiling your app to comment out some response and set up the data you expect, or for example, you try to call some function, but some condition is preventing you, so you adjust at compilation. Oh, sorry, okay. So that it's always true, so it will always get called. Or for example, there's some cumbersome function that does some calculation or some annoying animation that repeats over and over and over and annoys you when debugging. So you comment it out and hope to remember to re-enable it before you commit. Remember that Xcode has LLDB, and LLDB has some very convenient dynamic features. We all know and love the debugger of Xcode. We know how to set up breakpoints. We know how to print variables. However, I don't think that we always have this custom, and we don't always remember that LLDB provides a very nifty function called expression. So if you're in a situation, for example, you're trying to debug some reveal secrets method, but the feature flag is preventing you from doing this, don't recompile the code immediately, but as you enter the debugger, remember that by using LLDB, you can confirm the value by printing it, and then calling expression, you can assign new value to the feature flag active memory. And thanks to this, you can check that right now it's true. It has been altered dynamically by LLDB without recompiling the app. And you can immediately step over to the method you want to debug. So coming back to the example with the delegates, instead of recompiling the apps twice, I could have just set up the breakpoint, click edit breakpoint, and use a very convenient function, add action on breakpoint, in which I can set up xpre is short for expression, and I could check out my version with navigation delegate at first. There's even a convenient checkbox automatically continue after evaluating actions, which will prevent the breakpoint from stopping your app. It will immediately apply this fix at runtime, and you can validate if your fix really does what you expect it to do. However, sometimes there's a little bit, the situation is a little bit more tricky. Right here, we want to avoid calling update user state with validate set to true. However, we cannot use expression because there is no place in memory that we can override from true to false. However, there's another trick we can use. Again, with the breakpoint, right here, as I showed you before, we call the function with validate set to false. But if we do this, we call this function twice, so that's not what we expect. So we can add another debugger command and use a nifty function of LLDB called thread jump by 1, which will literally step over to the next line without calling it. Two functions, expression and thread jump. However, remember that using thread jump is exactly the same as moving the instruction pointer in Xcode. Whenever you see this green handle and you try to move it around, you get this dialog. Warning, instruction pointer may include crashing your application. This warning is not without a reason because the code you're reading is not the same the code your app is executing. There's automatic reference counting. It's extremely easy to introduce to over-release memory or to under-release it, which leads to a lot of protection faults from Xcode. So it's extremely easy to crash your app. If you're interested in debugging, I recommend Paul Hudson's Learn to Debug Like a Pro talk, which goes over a lot of tricks I covered today. It also has some information about the layout debugger. It's a really great talk. Just Google the title Learn to Debug Like a Pro, and it's going to be the first result on Vimeo. And also, I wholeheartedly recommend Advanced Debugging with Xcode and LLDB, this year's WWDC 2018 talk, which goes into great depth about what amazing tricks can you use from Xcode and LLDB. So wrapping up this section, recompiling takes time. So remember, you don't always have to do this. Xcode with LLDB provides you breakpoints which execute code. Remember to use expression that lets you to alter the app's state in runtime. Use thread jump to step over code that you don't want to run without recompiling it, but remember it's extremely easy to crash your app if you don't know what you're doing. So this is the time where we conclude our presentation. As you probably already figured out, there is no one magic tool that's going to help you all because there is no magic in debugging.
And as you could also see, there are many tools that can help you along, like Charles, LLDB, or Flex.
Even if some solutions overlap, because you can use Charles to modify some value at runtime, or you can use LLDB to achieve the same effect, having many tools means you have many options.
And we have showed you many issues that we met in our daily project life. And there are many tools, less and more difficult ones. But we find nothing wrong in using simple tools as long as they are working.
So we were really excited to take you through the 3 steps of debugging. We were happy that you were here with us, and the only 4th step we can do is to thank you for listening.
Thank you.
I have a question about this Charles tool. Could we configure it by some config file and run from command line?
So as far as command line is concerned, I see Kamil is smiling because he's a huge fan of meet and proxy tool. So basically it can do the same, but you can script it a bit, and it's available from command line. I think, Kamil, you agree? Yeah, so if you are more like a scripting person, I would recommend meet and proxy.
Curiosity, do you have like a lot of UI tests or using some UI test framework?
Yes, we are currently checking few approaches in our app right now, but let's say like in our main app, we have UI tests that are based on the KIF framework. It stands for Keep It Functional. And we are using stopped responses. It means that the test can go offline, and we use JSON files that contain information about responses and everything. If you'd like to know more, you can reach me after the presentation. I'll be happy to discuss it.
Yeah, of course, thanks.
For phishing, I need to buy some bugs. Can I find bugs on Allegro?
Not on production, sorry.
Not on production, but you can configure your app with the test environment, with shaking your device. Yeah, if you have some bugs you want to share with us, we are here to listen, of course. We don't have any bugs for him, right?
No.
Yeah.
Hello. I have a question because you mentioned the problem with the looped UI, and you said that the bug went to a UI kit guy. So you are divided like in divisions and UI team, backend team, and so on?
Well, yes and no. We have a special team that supervises the way Allegro is laid out on Android, iOS, and web. And we put a lot of effort to streamline the application, all of the channels to look the same. So we have a special division or unit that oversees this, and it comprises both of web developers, Android developers, and iOS developers. And due to the work they do every day, they become experts from layout, from all sorts of UI-related code. So we have a friend, Adam. If you're listening us, hi, Adam. If there's a very big issue, we always approach him, and he almost always has some great insight about how to fix it.
Thank you.
Okay, have you been using the debug features that LLDB offers, like writing own scripts in the project? So, for example, in the WWDC conference, there was a script that enabled nudging the view so it could be moved in the debug window when the application is paused. So I was wondering if maybe it's in so large company it's useful to write own scripts.
Well, we don't write scripts. We didn't come into a situation where we needed it yet, so maybe we'll be writing some in the future. And we were actually having a discussion with Ewa if we were going to show the nudging with the debugger, but we came to a conclusion that Flex can do this almost as efficiently as you saw on those GIFs. You can pretty much move the views at runtime, which was, we decided it's pretty repetitive over the nudging from LDB, so we removed that.
There was an example with an astronaut, and there was this score that was like moved from up to down using breakpoints.
Yeah. Okay, thank you.